Hello and welcome to A-Level Math. This is the fourth video in the series Geometric Progressions. In the previous videos we have covered the concepts of geometric progressions, but all of them included a finite GP. So we had some finitely many terms in the GP. But in this tutorial we are going to extend this topic and include an infinite GP series and how to find out the sum of such an infinite series. So this video assumes that you have already seen the previous videos. If you haven't, then please click on the I button above and then only move on to the lecture. So let's start. As of now, we know that for any GP series, the sum up to n terms is given by a times 1 minus r to the power of n by 1 minus r. Alright, this is the formula for the sum up to n terms of a GP. So this formula assumes that in all there are n terms in the GP, but now we are going to extend this to include infinitely many terms. Now understand carefully what I'm telling you. So suppose that you take r is equal to 0.1. Now what is r square? I'm just giving an example. We are just taking an example where our common ratio is 0.1. Our GP has a common ratio equal to 0.1. Okay, that's just an example. So what is r square? It's 0.1 squared, which is 0.01. What is r cube? It's 0.001. And in this way, if you say, for example, find out r to the power of 10, you will be having 0.000 some, I guess, 9 zeros, yes, and then thereafter 1. So this is a very small quantity, right? Now just think what value will it reach when we increase the powers. So eventually this will reach to 0 as this power tends to infinity. That means as we take higher and higher powers, if we increase the powers even further and let it go to infinity, infinity means some very large value, then as our power tends to infinity, then this r to the power of n tends to 0. So r power n tends to 0 as n, that means the power tends to some very large number, which is infinity. Okay, now this holds when we take r is equal to 0.1, but not only for 0.1. If you take any value which is less than 1, I mean any value which is less than 1 but greater than 0, then this will hold. So it's not necessary you have to take r is equal to 0.1. You can take even r is equal to 0.5 or 0.8 or 0.9. Just make sure that you're taking some number that is a proper fraction. Okay, when I say a proper fraction, I mean the numerator is greater than the denominator. So it's something like 7 by 9 or 8 by 10 or anything. So all these are examples of proper fractions where our r will be less than 1. Okay, and this is not the only case. We can even take the value of r to be between -1 and 0. Sorry, between -1 and 0. So my r lies between -1 and 0 as well. So say for example, you can take negative and positive proper fractions. That means you can take minus 0.1, minus 0.8, minus 0.9, anything as well. So make sure that you have to take r between -1 to 1. So let me reframe it. We have to take our r to be between -1, sorry, not equal to. It has to be strictly greater than -1 and strictly less than -1. If you take any value of r between -1 and 1, so it's a proper fraction, be it negative or positive, then as n tends to infinity, r to the power of n will tend to 0. This thing you have to understand properly. Okay, now let's get back to the formula Sn. Our Sn was a 1 minus r to the power of n by 1 minus r. Now we have a GP that has infinitely many terms. Like, so what I mean to say, suppose that if I take some GP a, ar and so on and so forth, and the number of terms is infinity. That means I want to find out this entire sum, all of these sums added together. Okay, so it's an infinite sum. So I want to find out what will be this sum in that case. So Sn, we want to find out Sn as n tends to infinity. So all I need to do is just take care of this thing. Okay, so this will be somewhat near to 0 because I've already told you that when n tends to infinity, this r to the power of n tends to 0. So Sn in that case will be actually equal to a 1 minus 0 divided by 1 minus r is equal to a by 1 minus r. This is the sum of an infinite GP series. That's it. So all you need to remember the formula is that a by 1 minus r, where a is the first term and r is the common ratio. So this is the formula for an infinite GP. So let's understand this further with the help of an example. Find the sum of the infinite, sorry for this space, there will not be any space. Find the sum of the infinite geometric series 1 plus 1 by 3 plus 1 by 9, so on and so forth. Okay, so I need to find out the sum. I know that the formula is a by 1 minus r. What is my a? A is the first term, which is actually 1. What is r? R is the common ratio, which is second term by the first term or third term by second term, whatever you want to say. So r is 1 by 3. So my sum in that case will be 1 by 1 minus 1 by 3, which is equal to 1 by 2 by 3, which is 3 by 2. This is the sum of the infinite GP. I'm sorry that I missed the infinitely many dots over here. So it's like 1 plus 1 by 3 plus 1 by 9 plus 1 by 27 plus dot 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 till infinity. So the formula for this infinite geometric series is 3 by 2. If the question asks you to find out this without these dots, this becomes a finite GP, and you have to apply that formula a 1 minus r to the power of n by 1 minus r, because if it is given to be a finite GP series, as in this case I wrongly typed it, so but actually I wanted to show an example of infinite series, so that is why I'm using the formula a by 1 minus r. Okay, so let's take one more example. Find the sum of infinite series 1 by 2 plus 1 by 3 square plus 1 by 2 cube plus 1 by 3 to the power of 4. So clearly if you see that this is currently not in GP because the common ratio is not constant over here. So if you divide this by this, you'll get something, and if you divide this by this, you'll get something else. So currently it is not in GP, but it can be converted into sum of two GP series. Okay, so what we can do, we can take all these 1 by 2's together and then take all these 1 by 3's together. So what we have is 1 by 2 plus 1 by 2 cube plus 1 by 2 to the power of 5, so on and so forth till infinity, and we take all the 1 by 3 terms together in another bracket. So it is 1 by 3 square plus 1 by 3 to the power of 4 plus 1 by 3 to the power of 6 dot 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 infinity. Okay, so this now is a GP and this is another GP, so we can find out, and these are infinite GPs, so we can just find them out separately and then add them. So what we have is, this is a is the first term, which is half by 1 minus, what is the common ratio? Common ratio is 1 by 2 cube divided by 1 by 2, so it's actually 1 by 2 square, so 1 by 2 square. And please do make sure that whenever you want to apply this formula, just make sure that this r is a proper fraction. In our case it is turning out to be 1 by 4, so 1 by 4 is a proper fraction, and then hence the sum can be found out. Otherwise you cannot find out the sum of an infinite GP. Okay, then for this second GP, we have our first term to be equal to 1 by 3 square divided by 1 minus my common ratio is 1 by 3 square as well, so you just divide this by this, you'll be getting 1 by 3 square. Again 1 by 3 square is 1 by 9, so this is also the value is less than 1, so we can apply the formula. Okay, now just simplify. 1 by 2 divided by 1 minus 1 by 4 plus 1 by 9 divided by 1 minus 1 by 9, which is equal to 1 by 2 divided by 3 by 4 plus 1 by 9 divided by 8 by 9. So let me write down it over here, it won't take too much of space. So it's 4 by 2 times 3, 4 by 2 times 3 plus 1 by 8, 9 and 9 will cancel out, so 1 by 8 is what left. Then 2, 3 to the 6 plus 1 by 8 gives me 6 1 by 8 as my answer. This is the formula, sorry, this is the answer to this infinite GP. Okay, next question. Prove that 6 to the power of half times 6 to the power of 1/4 times 6 to the power of 1/8 till infinity is equal to 6. Okay, so as of now you can see that there are products over here. So this is not actually a series, but what we can do is just add up all these powers. So we know that 6 power something times 6 power something. We can add all of these powers, right? It's simply because of the laws of index. So a to the power of m times a to the power of n is equal to a to the power of m plus n. By this, by the virtue of this formula, we can add up all those powers. So that's what I'm gonna do now. So I have 6 to the power of half plus 1/4 plus 1/8 up till infinity, and I have to prove that it's equal to 6. No problem. So now if you see this power is actually a GP. So what is the formula for it? 6 to the power of, what is a is my half, divided by 1 minus r is 1/4 divided by 1/2 will turn out to be half. So again it is less than 1, so we are good so far. So what is left out is 6 to the power of half by half. Half and half cancels out. What we are left with is 6 to the power of 1, which is 6, and this is what we are required to prove. That's it. Simple, nothing too much in here. Next question. Use geometric series to express 0.55555 or 0.5 recurring as a rational number. What they are asking us is to convert this 0.555 till infinity as a fraction. So it's something of the form p by q. We have to write it down as a fraction. Okay, so let's see how we can do it. So we can write down 0.5555, assume it's still infinity, as we can write this down as 0.5 plus 0.05 plus 0.005 plus 0.0005 up till infinity, because if you see, if you add all of them, you will be getting 0.55555. so I can expand it like this. Now I convert each of this into fractions. So it is 5/10 plus 5/100 plus 5/1000 plus dot 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 till infinity. Now I can take 5 common, or if you don't want, that's okay. So 1/10 plus 1/100 plus 1/1000 plus till infinity, and now this thing is a GP. So infinite GP. So we can apply the formula a, which is the first term, divided by 1 minus r, which is this, divided by this. So 1/100 divided by 1/10 gives me 1/10. Again 1/10 is a proper fraction, so we are good again. So it's 5 times 1/10 divided by 9/10. 10 and 10 cancels out. I get 1/9, so it is 5/9. So 5/9, if you do it in the calculator, if you see that you divide 5/9, you'll be getting this 0.55555. so that's 5/9 is our answer. Okay, the sum of first two terms of an infinite geometric series is 15. It's saying that there's an infinite geometric series. Okay, let's assume that our geometric series is ar square, and this goes up to infinity. So the sum of the first two terms is 15. That means they're saying that these two terms, if we add them, I get 15. So I can do a plus ar is equal to 15. This is my first equation. Let's see what we have other than this. And each term of the series is equal to the sum of all the terms following it. Okay, so they're saying that if you take any particular term, suppose if you take some term over here, then the value of this term is equal to the sum of all the terms following it. That means the value of this term is equal to next term plus next term plus next term all the way up to infinity. So in general, if you take suppose the rth term, then rth term is what? Okay, not the rth term, nth term, because r is already the common ratio. I'm sorry. So if you take the nth term, then the nth term is actually n plus 1th term plus n plus 2th term plus n plus 3th terms all the way up to infinity. So that means a r to the power of n minus 1 is equal to a r to the power of n plus a r to the power of n plus 1 plus a r to the power of n plus 2 plus all the way up to infinity. And now this is a GP, infinite GP as well, because constantly r is being multiplied and r is of course less than 1 because they are given in the question that this is an infinite GP. So for this infinite GP, my sum is, this is the first term, a r to the power of n divided by 1 minus r itself, because r is the common ratio. So what I get is that this a r to the power of n minus 1 is equal to this. Okay, so let's now cross multiply. A r to the power of n minus 1 minus a r to the power of n is equal to a r to the power of n. So what I have is a r to the power of n minus 1 is equal to 2 a r to the power of n. A and a cancels out and r cancels out with 1 r remaining. So we have everything cancelling out. 2 will remain, I'm sorry, a will cancel out. So we have 1 is equal to 2r. That means r is equal to 1 by 2. Okay, so we get the value of r. Now we just put the value of r over here to get the value of a. So let me write it down once again. A plus ar is equal to 15. So a plus ar is equal to 15, and we take a common. 1 plus r is equal to 15. R was equal to half, remember. So a 1 plus half is equal to 15. A times 3 by 2 is equal to 15. 3 5s are 15. So a turns out to be equal to 10. Okay, so we have got the value of a, we have got the value of r, and now the question asks us to find out the value of the series, the series. So the series is a ar, so a, then a times r, 10 times half, 5 by 2. All I'm doing is just keep on multiplying with a half because the first term is 10 and r is the common ratio. So all I need to do is just keep on multiplying by r. That's the very definition of a geometric series. So 5 by 4, 5 by 8, and so on and so forth. This is my GP. So the question doesn't ask you to find out the sum of this GP, but if you wish, you can also find out the sum. So just let me do it for you. So it's 10 by 1 minus half, which is equal to 10 by half, which is equal to 20. So the sum of this infinite GP series is 20, even though the question doesn't ask us, but just for the fun of it. Next question. The sum of an infinite geometric series is 15. The question gives you the sum. So they are saying that a by 1 minus r is equal to 15. So this is the first equation at hand. And the sum of the squares of these terms is 45. Okay. So let's assume our GP was ar square, ar cube, all the way up to infinity. Sorry. So the question says the sum of the squares of these numbers is 45. That means if you square these terms and then add them, so the square of a is a square, the square of ar is ar square, then ar square the whole squared, the ar cube the whole squared, this up to infinity. If you add all of this, you get 45. Now if you closely look at this, this is again a GP. Okay, because if you see this divided by this and then this divided by this is a constant. So this again is an infinite GP with my first term is equal to a square and common ratio, which is this divided by this. So let's quickly find out. A square r square divided by a square gives me r square as my common ratio. So this is the sum, which is equal to 45. So I have got two equations. One is this equation number 1, a by 1 minus r is equal to 15, and this second equation, a square by 1 minus r square is equal to 45. Let me write these two equations clearly again for your understanding. A by 1 minus r is equal to 15, equation number 1, and a squared by 1 minus r squared is equal to 45. I have two equations, and with these two equations I can just solve them together to find out the values of a and r. So let's quickly do that. So what I do is I square the first equation first. So if I square this, I get a square by 1 minus r the whole square is equal to 225. And now if I divide this equation with this equation, a is eliminated. So what I do is divide it over here itself. a square by 1 minus r square divided by 45. So a square and a square cancels out. What I'm left with is 1 minus r square by 1 minus r whole square is equal to 225 by 45. Now I can factorize 1 minus r square as 1 minus r times 1 plus r divided by 1 minus r the whole square is equal to, and this can be cancelled out with 15 15s are 25, 15 3s are 45, then 3 5s are 15. So I get 5 over here, and 1 minus r and this 1 square will cancel out. I have 1 plus r by 1 minus r is equal to 5. So 1 plus r is equal to 5 minus 5r. Then I have 6r is equal to 4, or r is equal to 4 by 6 is equal to 2 by 3. So I've got the value of r. Very good. All I need to do is just put it over here and find out the value of a. So r turns out to be 2 by 3, and a by 1 minus r I know is 15. So a by 1 minus 2 by 3 is equal to 15. A by 1 by 3 is equal to 15. A times 3 is equal to 15. A is equal to 15 by 3, which is equal to 5. So now again they ask us to find out the series. So my series is 5. Then 5 times 2 by 3. So 5 times 2 by 3 is 10 by 3. So it is 10 by 3. Again 10 by 3 times 2 by 3. So 10 times 2 by 3 is 20 by 3. Sorry, 20 by 9. I'm sorry, 10 by 3 multiplied by 2 by 3. So it is 20 by 9. Again this multiplied by 2 by 3 is 40 by 27. This goes to infinity. So this is my series. Okay, next question. The sum of a given the side of a given square is 10 centimeter. So we have a square. So this is my square, and the side of this square is given to be 10 centimeter. The midpoints of its sides are joined to form a new square. So this question says that I join all of these midpoints to get a new square. Okay, so we join this, we join this, we join this, and we join this, and I get a new square. Again the midpoints of this square are joined to form another square. Again we take the midpoints of this square, and in a similar manner we join these midpoints and get another square. And now they ask us, and this process is continued indefinitely. So we keep on doing it. So eventually we'll be getting smaller and smaller and smaller and very, very, very small squares. And now the question asks you to find out the sum of all these areas. So the bigger square has some area, so you find out this area, then you add this area inside it, then again you'll be getting a new square, so you add this area inside it, again you will be getting a new square by joining these midpoints, so you again join this area, again you will be getting a new square by joining this midpoint. So you have to keep on doing it, and what will be the sum of the areas. Okay, so let's see what we can do. First of all, I have a square, let me try it again, with side equal to 10 centimeter, and then I take midpoints. Now I'm just showing you what is the relation between these two squares, because this relation will be carried forward to every square. Okay, so for my bigger square has a side of 10 centimeter, I am interested in finding out the side of this square. Okay, so this is midpoint, so this is 5 and this is 5 and this is hypotenuse. So I know that this can be found out by root over 5 square plus 5 square, because by Pythagoras theorem we know that perpendicular square plus base square is equal to hypotenuse square. So hypotenuse is actually under root of perpendicular square and base square. So my hypotenuse is actually root over 5 square into 2, which is 5 root 2. Okay, so I get my this side to turn out to be, so what I'm saying is that for this inside square my side is 5 root 2. So what is the relation? The relation is that every time I do it, what is 10 by 5 root 2, it just turns out to be 1 by root 2. 1 by root 2. So the question says that every time I do it, I get a new square whose side is 1 by root 2 of the previous square. What I mean to say is that our bigger square was having a side of 10 centimeter. Now if you multiply 1 by root 2 to it, you will be getting 5 root 2. So the inner square will be having a side of 5 root 2 centimeter. And again, if you do it once more, that means you form one more square inside it, then the new square will have a side of 5 root 2 multiplied by 1 by root 2, which will be actually 5. And this will go on. Then for the next square it will be again 1 by root 2. For the next square again it will be into 1 by root 2. So I'll be having a square, I'll be having squares with sides constantly getting multiplied by 1 by root 2. Okay, so what is the area of the first square? The area of the first square is 10 square. Of course, that's side square. The area of the next square is 5 root 2 the whole square. Then the area of next squared is 5 the whole square, and this goes on till infinity, right? So this is a GP now. Why GP? Because constantly 1 by root 2 is we have to find out the common ratio by this divided by this. So what is my A? A is my 10 square, which is 100. So A is 100 by 1 minus R is 5 root 2 square by 100. So 5 root 2 square divided by 100, which is 25 times 2 by 100, 25 4, and then this is half. So I have 1 minus half. So it turns out to be 100 by half, which is actually equal to 200. So this is the sum of all those areas. Okay, and now it asks you to find out the sum of the perimeters. So again we have our first perimeter to be equal to 4 times the side, which is 4 times 10. The next perimeter will be 4 times 5 root 2. So it is 5 root 2 plus next perimeter is 4 times 5, and this goes to infinity. And now I can take 4 common. I get 10 plus 5 root 2 plus 5 up till infinity, and this again is a GP. So keep 4 as it is. The first term is 10 by 1 minus R is 5 root 2 by 10 will be 1 by root 2. 1 by root 2 is equal to 4 times 10 by root 2 minus 1 times root 2, and then I can just multiply 40 root 2 divided by root 2 minus 1. And then if you want to simplify it further, that means rationalize, then you can multiply with root 2 plus 1 in the numerator and denominator to see what you get. So 40 root 2 times root 2 plus 1 by root 2 minus 1 into root 2 plus 1 is root 2 square minus 1 square, which is 2 minus 1, which is 1. So my final answer is 40 root 2 times root 2 plus 1. Or if you want, you can multiply this root 2 inside. So I get 42 plus root 2. This is my final answer. Okay, I hope this is the final question. So this bouncing ball is for your understanding, but first look at the question carefully, then we will go into the bouncing ball. After striking a floor, a certain ball rebounds 4 by 5 of its height from which it has fallen. So suppose that you drop this ball from a height of, so suppose that you drop it off from this height. Okay, no, it's going even further up. Yeah, so assume that you're falling this ball from this height. Okay, now the question says that it will again jump back and it will rise up by 4/5. So in this animation you are seeing that it is going up the entire height again, but I don't want that. The question says that it only jumps back to 1 by 4th of its height. Sorry, 4 by 5th of its height. I'm sorry, 4 by 5 of its height. So this is somewhere the new height, and then again when it goes back down, it again rises up or bounces again for the 4 by 5 of its height, and this goes on. So we want to know what is the total distance that the ball will travel before finally coming to rest. let's read the question once again. After striking the floor, a certain ball rebounds 4 by 5 of the height. That means it bounces back 4 by 5th of the height. So it will not reach the entire height. It will be somewhere less, somewhere below the original height, and which is of course obvious. It cannot bounce more than its actual height, which it has fallen. Find the total distance that it travels before coming to rest if it is generally dropped from a height of 120 meters. So suppose that it is generally dropped from a height of 120 meters. So 120 meter it covers in the first time. Then it again bounces back and reaches the height of 4 by 5 of 120. But this distance is covered twice. Why? Because so this is the height with which it was fallen. Okay, so this is the height with which we've allowed it to fall, and then it again bounced back to 4 by 5th of its height, and then it returned. So this height 4 by 5 of 120 was covered twice. Okay, so this distance was covered twice, and similarly again 4 by 5 of this new height is again traveled back. So 4 by 5 of this height is, so what I do is multiply 4 by 5 in this expression. So 120 times 4 by 5 times 4 by 5, and I write 4 by 5 the whole square into 120, and again this distance is traveled twice, and this will go on till infinity. Okay, so if you observe that from here till infinity is a GP. For this GP I can take 2 common outside, so I take, for every term I take 2 outside. So this becomes my GP. Okay, so the sum will be 120 plus 2. Then this is my first term, A, 4 by 5 times 120, and my common ratio is this divided by this, which will be actually 4 by 5. So 1 minus r, which is 4 by 5, and all I need to do is just simplify. So 5 times 120 is 5 2s are 10, 5 4s are 20. So I have 120 plus 2 times 96 divided by 1 by 5. So I have 120 plus 960, which is equal to 1080. So this is the total distance, 1080 meters, that is traveled by the ball. That's it. Thanks a lot. We come to the end of this GP series. I hope you like this entire series. I mean the geometric progression series on our video, not the GP series. So keep watching A-level math. Thanks a lot. Study hard and study smart. Bye bye.